Well, here's a fun little demonstration of magnetism in the right-hand rule. Let me show you what we've got here. First of all, a cylinder, it's aluminum, so it doesn't interact directly with a magnet. And then here's a bunch of little magnets. And these are also aluminum rails. So aluminum is a good conductor. And you can see there's a little bit of a gap in between these two pieces of metal. So if I were to turn on my power supply and clip and complete the circuit, there's a potential difference, high potential to low potential across this rail. So this whole metal rail is at a high electric potential because it's connected to the positive terminal, and this whole metal rail is at a negative potential, but the two don't touch each other, so there's no current being conducted at all. I've got 0 current on my meter, although I have 6 volts of potential difference. Let's turn that up just a little bit. Now I can bridge the gap from high to low potential using the little cylinder. If I put it on here, now a current will flow across the cylinder from high potential toward low potential. So let's disconnect for a moment. And now if I put this on, there's no current because I don't have a potential difference. I will once I complete the circuit. So if we've got that right, if current's going to flow from high to low, we know we can put our thumb in this direction. The question is, what's the orientation of all these magnets? Now I do know I'm the one who glued them in place and they're all facing in the same direction, but I don't know if you're looking at a bunch of north poles or you're looking at a bunch of south poles, but we'll be able to figure it out based on the right-hand rule. Our thumb points this way. Let's figure out what the direction of force is on this current carrying cylinder. So how do we use the right-hand rule for that? I know my thumb's got to go this way. Right, my palm has to face this way because that was the direction that the rod was forced. So what's that tell us? That magnetic field lines were pointing upward, so we can conclude these are all, that's right, they're all north poles. Now, if I reverse the polarity, this time when I place the conductor across the rails, current is going to flow this way. And since we agreed these are all north poles, magnetic field lines will point up and a current will flow in this direction, so now we'll get a force that away. Let's see if that's right. We got no force at all. Oh no, there we go. There you have it, another example of the right-hand rule.